Limited was founded in 1954 to supply the aerospace industry with components, and we now produce and supply motors, generators, electromechanical actuators and electromagnetic devices, as well as the components that we originally set up to do: springs, pressings and machine parts. We now develop our own products, and this is where this NATEP project has come in to support us developing our own magnetic bearings.
My name is Lee Stanger and I'm the lead R&D engineer here at NEMA, and I'm talking to you about EVAMBA, which is the experimental validation of active magnetic bearings for aerospace. NEMA are primarily an aerospace motor and generator manufacturer, and we found that bearings were one of the main limiting factors to our high-speed offerings. And we looked at magnetic bearings and decided that there was a lot of overlap between motor manufacturing processes and magnetic bearing manufacturing processes. So we decided that this would be an ideal technology that we could develop in-house. One of the beauties of magnetic bearings is because there's no contact with the rotating parts, there's no friction, no wear. So the applications where you need high speed for a long duration with low maintenance is ideal. So they're already used in some oil and gas applications, and we want to take them into primarily turbo compressors in aerospace. We have a lot of experience manufacturing and designing and manufacturing motors for aerospace, so we know how to make the manufacturing processes streamlined as simple as possible. And we used all of that in EVAMBA to minimise the winding complexity, and therefore making it easier and simpler and cheaper to wind.
One of the key innovations of the project has been this segmented approach to winding. In the past, when we've wound stators as a whole, we've had to preform coils and fit them through these small slot openings. This segmented approach means we can now hand wind the copper around the teeth. We've achieved a near 50% slot fill, which has greatly improved the performance and the power density of the stator. To achieve this, we used an iterative approach which required all facets of the company to work together. For example, this is one of the test segments that we used to acquire the correct tolerancing before making the real thing. At NEMA, we have the capability to manufacture and inspect to very tight tolerances to an aerospace standard. This was definitely the case on the EVAMBA project, for which we used the EDM to precision machine and the CMM to accurately inspect that all dimensions fell within the required limits.
My name is Niall Weldon and I'm an apprentice machinist at NEMA. We use the EDM on the EVAMBA project because there were very tight tolerances and it was a very complex shape. You can see the wire followed the track round here by a profile determined by the CAD, and you can see we also got a very good finish on this, better than we would ever get on a milling machine. For this project we made everything in-house using our high precision machining equipment. We have 3 lathes, 2 milling machines and 1 CNC grinder.
At the moment you just have to schedule in maintenance. Active magnetic bearings incorporate real-time feedback. This allows you to plan maintenance based on the data that you're getting back, rather than scheduling routine maintenance.
This is our radial bearing magnetic test rig. This is a static characterization rig, and what we've done here is created a map of the force as a function of current and position of the rotor. This will allow us to have very tight control of the system in future. The prototypes developed during EVAMBA are going to be used by the University of Nottingham to develop the control side of the system. So because we fully characterise them statically, they can be used immediately in a reduced degree of freedom test rig. During EVAMBA we developed these components to TRL level 4, and what we need to do now is to develop a whole system to TRL level 6.
What this funding has facilitated at NEMA is the ability to develop these magnetic bearings to a stage where we can now realistically go to market. Before, we were envisaging these magnetic bearings on paper, a bit of computer screen design, but nothing tangible. Thanks to the NATEP funding, we've built prototypes, we've tested them, and we have results. And we can now take those results and have productive, comprehensive conversations with academics, with customers, and we're now going for another grant to actually take that to a full system development for an aircraft engine. Some of the wider benefits from this project are, for instance, in the winding department. We have now developed a brand new procedure for designing, producing, inspecting and testing stators. So usually we do a complete circle stator, much like you see here. In this project we developed segmented laminations. Thanks to the NATEP funding we were able to put in the correct and necessary amount of resources, and the result is we have a new process that we believe we can take to the wider market for our generators, motors and other products for other aircraft. The next stages of this development are to develop a full system. We have components that have been developed very well to a certain stage, but now we're going to take them and develop them into a full system to customer requirements. We already have customers lined up for this, and we are going to set up a subsidiary business such that we are going to set up automated production lines for this. This is why we did the segmented laminations, for instance. At the moment, NEMA is set up as a highly skilled SME. Every job we do takes a lot of time, a lot of labour, and it's highly skilled work. We want our magnetic bearings production line to be more automated and to bring automation to Rochdale in the electric motor industry. It's meant a great deal. Being funded by NATEP and the ATI and approved to do the project has made me feel like NEMA is recognised and listened to and known as pioneers in developing electromagnetic technology for aerospace.
For me, the nice thing about this project has been that NEMA have taken their expertise in motors, they've applied it to magnetic bearings, and in doing so they've opened up a whole new set of markets themselves. They've used the NATEP funding to maximal advantage